Okay, so now we're going to answer now part B on exercise 5.3. Okay, let's recall. Uh, this is our free body diagram. This is our setup. In part A, we have the chain, have the maximum and the minimum and the wrecking ball. Okay, so so let's read it again. So we have a 75.0 wrecking ball hangs from a uniform heavy-duty chain of mass 26.0 kilograms. So this must be this one. A chain, a wrecking ball. So the chain must be attached from something. So find the 10 maximum tensions and the minimum tension of the chain. So we have our answer. We already answered that. So what is the tension at the point 3/4 of the way up from the bottom chain? Okay. So meaning uh so from the bottom chain, so we're gonna cover 3/4, 3/4 at this point. Okay. Okay. So meaning, so it means that it looks this. Okay. So we have the chain, we have the wrecking ball. Okay, we have the weight of the chain is equal to the mass of the chain times G. And we have the weight of the wrecking ball. The mass of the wrecking ball times G. Okay. So at this point, meaning what is the 3/4? Okay. If you're gonna divide this one by one half or by 4, so we have 1/4, uh, one half, and 3/4. Okay, at this point. Okay. At this point, okay, if you do the free body diagram at that point, so gonna looks like this. Okay. So you have the tension. Okay, what we're going to use is just tension T. And and here the weight of the wrecking ball or the weight total is just equal to the weight of the wrecking ball plus 3/4 times the weight of the chain. Okay, why? Because at this point only 3/4 of the uh only this part is pulling this point. Okay. So let's now proceed. So so the weight of the wrecking ball from part 1 is 735 Newton. Okay. So s- okay, so summation of all the forces along Y. So we have the tension plus the weight total plus the negative of the weight total is equal to 0 because equilibrium. So the tension is equal to the weight total is equal to the weight of the wrecking ball plus the 3/4 weight of the chain. Okay, let's determine what is so from A, we have the weight of the wrecking ball is equal to the mass of the wrecking ball times G is equal to 75.0 Newton. Okay, multiplied by 9.8, we have 735 Newton. Okay, what is 3/4? The weight of the chain. Okay, so the 3/4 is 3/4 times the mass of the chain times the acceleration due to gravity. So we have 3/4 times 26.0 kilograms. Okay. So I'm sorry, this is not Newton, this is kilograms times 9.8 meters per second squared. Okay, therefore, times 26 times 9.8. So we have 191.1. Okay. So 191.1 Newton. Okay. Don't convert it to three significant figures yet because this is not our final answer yet. Okay. So from this equation, equation 1, so we have the tension is equal to the weight of, so we have 735 Newton plus the weight of this one, 191.1 Newton. Okay. Okay. So we have 926.1 Newton. Putting it in three significant figures, it will become 926 Newton. Okay. So that ends our exercise 5.3 part B. So thank you for watching. Please leave a comment if you want more videos like this.